Welcome you all to our very first class of mathematics of class 9. So here the first chapter is number system. It's a very vast topic, and also in class 10 the first topic is related to this, out of which 6 mark will come in your board exam Cbse class 10. So this chapter is very important for that point of view. Many new terms you will know in this chapter, but the point is you have to keep your patience. With time, with passage of time, one by one new topic, new concept you will know. The first domain and the first, I will say, aspect of number system is natural number. So as you know from your earlier classes, is nothing but the counting number, the number we used in our daily day-to-day life for counting purpose. Just like 1, 2, 3, 4, all are natural numbers, and it is represented by by alphabet n. Then we will come to the next number system, which is whole number. So it is includes all the natural numbers that just we discussed along with 0, means 0 and all the natural numbers. So and it is represented by the alphabet Z. So the next number system is integer. So it includes all the positive numbers, that means the natural numbers 1, 2, 3, 4, 5, 6, 7, and all the negative numbers. Negative means the minus of what? Of the natural numbers, minus 1, minus 2, minus 3, minus 4, along with 0, means 0 in the middle. In the right side all the positive numbers 1, 2, 3, 4, 5, 6, 7, left side all the negative numbers minus 1, minus 2, minus 3, minus 4. So this is the integer, and it is generally represented by Z, sometimes also by I. And the next number system is rational number. That is the first topic of your class 8, you have discussed in detail. So rational number is something which we can represent in the form of P by Q, where P and Q belongs to Z. We can say that a rational number is A by D. So here A and D are not integers. Okay, so any number can be represented in the form of P by Q, where P and Q are integer, and Q is not equals to 0, is a rational number. The example, 1 by 2, 3 by 5, minus 8 by 9, minus 1000 by 2 lakh. So all these numbers come under the domain rational numbers. The next we will discuss the very new concept is irrational number. So we can define irrational number, we will discuss it, but before that just try to understand irrational number in terms of rational number. So what is rational number? The number which can be represented in the form of P by Q. So what is irrational number? It is exactly the opposite or complement. It is the exact opposite of rational number. The number which can't be represented in the form of P by Q is irrational number. So for very first example, the famous example is root 2. So root 2 is an irrational number. Why? You will say, sir, I can represent it by root 2 by 1, because you said if there is nothing in the denominator means 1. So root 2 equals to root 2 by 1. But the point is next line. So here the P and Q are root 2 and 1. So is root 2 a integer? Have you ever known integer? Whatever you know, is root 2 among them? No. So root 2 is not an integer. So root 2 by 1 is not an irrational number. So here we will discuss what is irrational number now, which is not in the form of P by Q. And please see the graph or the picture I have drawn. So one part, one room or one aspect is rational, exactly the other is irrational, and the combination of both rational and irrational is the real number. So what is real number? It is the combination of both rational number and irrational number. So the definition of real numbers, the exact one, combination of both rational and irrational, or we can say it, the number which can be represented or positioned on a number line. So you have drawn number line for natural number, for integer, for rational number. It is saying on that particular number line, all the possible points, each point denotes a real number. So in number line 1, 2, so there are many numbers between 1 and 2. There are many space between 1 and 2, or 2 and 3, or minus 8 and minus 10. So that gap, each point represents a real number. So the number which has existence on the number line is real number. Okay. So next we will discuss something more about irrational number. So check it. I have find the square root of 0. So it is 0. Square root of 1 is 1. Square root of 2 can be calculated, means it's root 2. If we multiply root 2 into root 2, it is square root of 2. Similarly 3, 4, 5, 6, 7, 8, and here comes 9. So square root of 9 means which number you multiply twice to get 9. So it is 3. Which number you multiply twice to get 10. So it is root 10, means no number is there, so that we can multiply it twice to get 10. Okay. So in this example also, this side in right side you may see 1 by 2, square root of 1 by 2. So here 1 is multiplied with 1 to get 1, and root 2 is multiplied with root 2 to get 2. So 1 by 4, 1 by 2 into 1 by 2 is 1 by 4. 1 by 3 means numerator will be 1, denominator will be root of 3. Root over of 36 by 49, which is multiplied twice to get 36, it's 6, which is multiplied twice to get 49, it's 7. So here I have find out the square root of many numbers. Okay. So you can see the square root of the square number. Square number means 1, 4, 9, 16, similarly 25, 36, 49. So the square root of these numbers are, we have written here. So these are rational, means the outcome, the result is something that I know already before, so which can be represented in the form of p by q. So that's rational number. But there are some such numbers are coming which are not rational, just like which numbers you multiply twice to get 2. So 1 into 1 is 1, 2 into 2 is 4. So there is no such number that I multiply twice to get 2. Okay. So the answer itself is root 2, means I can calculate it. So it is as it is, square root of 2. So these type numbers are the irrational numbers. Also in you are saying, sir, only natural numbers I can calculate the square root. No, we can calculate it of some rational numbers that I have in fractional form. 36 by 49, it's possible. 6 by 7. Okay. So 6 by 7 is rational, or square root of 36 by 49 is rational, but square root of 11 by 10. So no number is multiplied twice to get 11. No number is multiplied twice to get 10. So square root of 11 by 10 is irrational. Now I think a little bit of concept of irrational number is clear. But if I check the next slide, at it is written -1, square root of -1. Is it possible to multiply two numbers that you will get minus? Because we have discussed the multiplication of two negatives. Even number of negative is positive. -1 into -1 is +1. Suppose I am writing here -1. Which two numbers will multiply to get -1? If you will take two positive numbers, the multiplication is 1. Two negative numbers, the multiplication is 1. You will say, sir, I will take one positive, one negative. Then this is not a square. You will take 1 and -1. So this is not square of any number. Square means a same number multiplied twice. So whenever a same number will be multiplied twice, then the result is always positive. So the square root of -1 is not possible even. There is no existence. So the square root of not only -1, the square root of any negative number, -25. So -25 you can calculate, it is -1 into 25. 25 square root you may get it. But what about square root of -1? It is not possible. So square root of any negative number is not possible. It has no existence. So this is not a real number also. Sorry, I have written here irrational number. This is not a real number also. Okay. So rational is already we have discussed. Irrational, what I can calculate, but the square root of the negatives, it has no existence. So these are also not the real numbers. So if I will summarize, the square root of positive numbers are real numbers. The square root of negative numbers have no existence. They are not real. Clear? Square, listen carefully. Square root of positive numbers, any positive numbers. Okay. Square root of any positive number is real. The square root of any negative number is not real. So this is not our consideration, we will not discuss that square root of negative. So now we have one aspect remaining, square root of positive numbers. So among positive numbers there are two types of numbers, one is square number, another is non-square number. Here square number means perfect square, just like 1, 4, 9, 16, 25, 36, 100, 36 by 49, 16 by 64. So these are the square of something. Okay. So the square root of positive square numbers are rational, and the square root of positive non-square numbers. So non-square means your which is not in square form, which is not in perfect square, 11 by 10, 16 by 32, 11, 13, 19, 21, 23, 27. So these are not square of anything. So the square root of this non-square number is irrational. Now I think little bit your doubt is clear. What is irrational? The square root of positive non-square numbers. And you think the prime numbers 2, 3, 5, 7, 11, 13, 17, 19. So is it square of something? Is any number multiplied to twice to get the prime number? No, the prime number has only two factors, 1 and itself. So prime number is not square of anything. So prime number is not a perfect square, it is not a square number. So what will be its square root? So the square root of all the prime numbers are irrational. Okay, I will summarize again, just listen it carefully. 3 sentences I will say. Square root of positive numbers is real. Square root of negative numbers is not real also. Clear? Then in positive numbers two types numbers come, square number, non-square number. Square root of square numbers are rational, square root of non-square numbers is irrational. Okay, so in non-square numbers your prime numbers come, they are not square of anything. So the square root of prime numbers is irrational. So you can check root 2, root 3, root 5, root 7, root 11, root 13. So this is the square root of the prime numbers. So they are irrational. Also square root of 8. Okay. So this is we are writing 2 root, we have calculated in class 8. So all these are irrational numbers. So next we will go to the graph, very important one. Almost 1 marks always come from that aspect. Just we will check it. So look the graph carefully. So the least number here, the least domain is natural number n. I have marked in circle. So the circle denotes natural number. When I add something extra space, so the only extra space is 0. 0 along with natural. Now I have created the triangle. Okay. So triangle denotes W, whole number. So the next is Z. So here Z means the integer. Means here is natural number. See, the circle is here. Yes. All the natural numbers or all the positive numbers and all the negative numbers. Here negatives of natural along with 0. So 0 means inside the triangle W is there. So inside the triangle there was positive as well as 0. And except the triangle in between the rectangular shape, there are some negative numbers, minus 5, minus 10, minus 8. So the rectangle denotes your total integer. Okay. And in the integer there is natural number n in circle, there is 0 in triangle, and also some negative numbers which is not in triangle but in the rectangle, in the outer space of the triangle. Okay. So next is rational number. So the rational number, any number in the form of p by q. So here all the natural numbers are there, we can represent in the form of p by q. All the negative numbers are there, we can also represent them in the form of p by q. 0 is also a rational number because 0 equals to 0 by 1. 0 is integer, 1 is integer. So all the integers along with some extra numbers which are not integers is rational numbers. So your rectangle represents the integers, along with there are some more numbers that is not in the rectangle, means not the integer but are rational. Example 2 by 5, 3 by 7, minus 8 by 13. So all these numbers are included in the rational numbers. So here rational number is denoted by q in the pentagon. Are you seeing the pentagon? Okay, rectangle is integer, pentagon is rational number. Okay, so next we will go to the next number is irrational. So irrational is the number which is not in the pentagon but in the hexagon, are denoted by the shaded portion. Means I have shaded it, I have colored it. Okay, so see what is real number? I have said real number is the biggest number system till we have known. Okay, so real number is the combination of both rational and irrational. So the pentagon denotes the rational number. Okay, pentagon, see q denotes the rational number, and the outside of q, the biggest domain, is real number, and in between the r and q there is the shaded portion is irrational number. And you see the pentagon is rational. If you will add the shaded portion, you are getting a bigger picture, that is a real number. Okay, so next we will go to some important questions that always comes in exam. So is natural number a whole number? Is whole number a integer? Is integer a natural number? Just like these questions. So for that you have to think true means what. Suppose you will say, sir, man has one leg. I will say no, false. You will say no, sir, it is true, because in my village there is one person who has one leg. Okay, so keep it in mind. True means the statement is true if it is always true. Means I will say man has two legs. So yes, it's always true, except some exceptional case. Except some exceptional case means out of 1000 or 1 lakh, I will get 2 or 3 persons which has one leg or which has no legs due to some accident or something. Keep in mind, true means not by chance. For one case it is true. The statement which is always true is true. So with this we will go to the next slide. See here, I have written n is a subset of w, is a subset of z, is a subset of q, is a subset of r. Or subset you can just replace it through the lesser than symbol, not exactly same but for understanding purpose, lesser than symbol. In that number system, which is the least safe? Which number system has very small shape? That is the circle. It is a very little one. The circle has the least shape. Then the next bigger one is the triangle, means w. The next bigger one is the integer. Okay, means the rectangle. The next bigger one is the q, rational number, pentagon, and the biggest one is the real number, that is the hexagon. So is it clear? Natural number is a small domain under whole number, which is a small domain under integer, which is a small domain under rational number, which is a small domain under real number. So you can say every natural number, see I have written arrow mark left to right is correct. Okay, I forgot to complete it. It is correct, sure, correct. So left to right is always correct. Means every natural number is a whole number, every natural number is an integer, every natural number is a rational number, every natural number is a real number. Okay, because natural number is very small, it is between every number, but not in irrational. Irrational is something extra, forget about it. We are talking natural, whole, integer, real. Okay, natural number, whole number, integer, rational number, and real number. Forget about irrational, it is something extra. Okay. So the smaller one, left to right, natural, whole, integer, rational, real. So left to right is always correct, but the opposite may be correct, may not be. Okay, so the reverse is incorrect, left to right is correct. Then we will say, what about irrational? Yes, irrational is only a domain of real number. So every irrational number is real number, but irrational has nothing to deal with other systems. Means it is rational's opposite, which is not rational. Okay, which is not a man, that's an animal. So irrational is something like that. So there is no profession in between the irrational number. Doctor, police, teacher, farmer, all these among the human beings. So all these among the rational number. Okay, animal is something which is not a man, so that is irrational. So keep it in mind, irrational is something extra. So no number system except real number has relation with irrational. It is the opposite of rational. Next we will discuss how to find rational numbers between two given rational numbers. See, 0 to 1, okay, may be divided into how many equal parts? I have written fill in blanks. 0 to 1, that line, can it be divided into 2 equal parts? Yes. So each part is a rational number? Yes. Can it be divided into 3 equal parts? Yes. So there are 3 rational numbers in between them. Can it be divided into 10 equal parts? Yes. So there are 10 rational numbers in between them. Can it be divided very small 20 parts? Yes. Then there are 20 rational numbers in between them. Okay. So these two lines, sorry, if I'll say in the left side also -2 between -3 or -5 between -10, in between any two rational numbers, the space, the distance can be equally divided into many number of parts. It may be 10, 20, 1000, lakh. So in between two rational number, how many rational numbers are possible? It may be 2, it may be 10, it may be 100, it may be 1000, it may be lakh, it may be infinite, not countable. So keep in mind, in between two rational numbers, there are infinity, uncountable number of rational numbers. Now we will discuss how to find those irrational numbers. For example, I will say one number is 4 by 10, another number is 8 by 10. It is written on the material. So in between 4 by 10 and 8 by 10, what are the numbers? You will say, sir, denominator is same, 10, 10. Numerator is 4, another is 8. So in between 5 is there, 6 is there, 7 is there. So the rational numbers are 5 by 10, 6 by 10, 7 by 10. Similarly, if any two rational numbers are there, if the denominator is same, we will write the numerators in between them. But the problem is, if the denominator is different, how to make it? Simply, if they are different, you make it equal by taking that LCM, and when the denominators are same, you can easily find the numbers in between the numerators each by the denominator. So here I have taken a very small example, 3 by 5, 5 by 6, make the denominator same, 30 and 30, okay. So then the numerator is 18, 25. So in between 18 and 25, there is 19, 20, 21, 22, 23, 24, each by 30. So are the rational numbers between 18 and 25. Suppose I will say, find 20 rational numbers between 18 by 30 and 25 by 30. You will say, sir, there is only 6 numbers, but I need 20. What to make? I will little bit more expand, just like elastic. The more you will expand, the more it will go. So if it is being squeezed, then we expand it. How to expand? Find the equivalent rational number greater than that. So here is another example, 40 rational numbers between 3 by 5, 5 by 6. So make the denominator same, it is 30, 18 by 30, 25 by 30. Okay. So there are hardly 6 to 7 numbers, but I need 40. So what I did, I little bit expanded, means 30, okay, some mistake is there, it is 180 by 300, 250 by 300. So 30, 30 is the denominator, I will make it expand, means let's multiply 10. Then but the same number, you will say, sir, is it mandatory to multiply 10? No, you may multiply any number, 10, 5, 30, 50, 60, according to your convenience. So I multiplied 10 in the numerator of 18, in the denominator 30, also in the numerator 25 and the denominator 30. So the number becomes 180 by 300 and 250 by 300. See, the denominator is same, 300 and 300, and the numerator is 180 and 250. So in between 180 and 250, there are 70 numbers, 181, 182, 183 by 300. Just keep in mind the mistake is there. I have written there 30, that will be 300, 300. So there is another method to find rational numbers in between two given rational number. So here I have taken, for example, 100,000. Actually it is wrong, it is 0 and 1000. I just prepared the material in a hurry, so there are some minor mistakes. So it is in between 0 and 1000. So in this method, what I will do, I will find the exact middle number, then in between two, again I will find the middle one. Just I will go on finding the middle one, and as you know, there is the in between space, there are infinity numbers, so there are infinity middle numbers, I will get it. So in between 0 and 1000, so one number is 500. In between 0 and 500, again I will find the another middle number, it is 250. In between 0 and 250, again you will get 125. So if you 0 and 125, you will find it, you will get 125 by 2. Again 0 to 125 by 2, you will get 125 by 4. So if you go on in between two rational numbers, you just find one exact middle number, then between the first and the middle again another middle number you will get. Similarly, you may get infinity number of rational numbers. So here I have just taken a very small example. Find three rational numbers between 2 by 5 and 3 by 8. So it is half of 2 by 5 plus 3 by 8. I have calculated 31 by 80. Again half of first one is fixed, 2 by 5 plus 31 by 80. I got it 63 by 160. Again half of 2 by 5 plus 63 by 160. I got it 127 by 320. Here I move towards left side. You may move towards also right side. You may got the half 31 by 80. Again half of 31 by 80 and the right one 3 by 8. Whatever value we get, next step we will find the middle one of that number and the extreme right position. So in this method you may proceed. But I think if there is to find many numbers, 10 numbers, 8 numbers, 5 numbers, you follow the first method. I think that's easy. So this is your first exercise. Question number 1 already discussed. Question number 2, you may find it. 3, then 4. Every natural number is a whole number, every integer is a whole number, every rational number is a whole number. Just keep in mind that natural number, whole number, integer, rational number, real number, left to right is always correct. Okay, but don't consider it irrational. There is another aspect. Irrational number is a real number. Every irrational number is an irreal number. So we will not discuss much about irrational number, but we will discuss how to represent them in number line. As we have discussed, real number, every real number can be represented on the number line, and real number, this is divided into two parts. One is rational, another is irrational. So rational already we have discussed. Now we will discuss how to represent irrational in the number line. So before that, I would just like to recall one concept, that is Pythagoras theorem. So this is for right angle triangle, p square plus b square equals to s square, and your p and v are the adjacent side of right angle, whereas h is the opposite side of right angle. Okay, so how it will help you? So h square, for example, here I will write p as 1, b as 1, it is 1 square plus 1 square equals to h square, means h square means 1 square plus 1 square is 2. So h square is 2. H square is 2. Listen, h square is 2. So what is h? It is the square root of 2. If I will make square in both the sides, root 2 square. So root and square it is cancelled. So it is 2 and h square is 2. Clear? So h is root 2. So this method we will use to find the, to represent the irrational numbers. So any irrational number is there, just like here it is root 2 is there, maybe 3 is given, maybe 8 is given, maybe 12 is given. So as 2, 3, 8, 12, 15, 18, so all are not perfect squares, so its square root is irrational. So how will show it in the number line? We will think such two numbers whose square gives 2, 3, 18, 15, whatever number is there. Okay, so in this case it is 2 root 2. So we will think two numbers whose sum of its squares gives 2. For example, 1 square plus 1 square is 2. If it will ask to find 3, root 3, so first the sum of two number is 3. So this is 2 plus 1 is 3. So 2 is root 2 square and 1 is 1 square. So if we will take root 2 and 1 as p and b, we will get root 3. Similarly, root 5 means the sum of two numbers should be 5. So sum of two numbers here it may be 4 plus 1. So 4 is 2 square, 1 is 1 square. So 2, 1, if I will take p and v, I will get 5. That means root 5. You will say, sir, 3 plus 2 is also 5. Yes, very good, correct. So 3 is whose square? Root 3 square. 2 is whose square? Root 2 square. So I can take 3 plus 2, but it will be complicated. Okay, so let's see how to find it. First, the concept is clear, Pythagoras theorem, then we'll go to the exact one. So here we'll discuss step by step procedure. So first we'll think such two numbers p and v whose sum of square gives the rational number. For example, here is root 2, I have to find out, so it will be in h. So root 2 square is 2. So whose two numbers square gives 2? It is 1 square plus 1 square. So the value of p and v is 1 and 1. So after finding the value of p and v, we will take them in x axis and y axis. Just like I will draw x axis, y axis perpendicular to each other. Okay, in x axis I will take 1 unit and in y axis I will take 1 unit. It is now a right angle triangle. I will complete the triangle and I will get the diagonal. So the value of that diagonal is √2, but that diagonal is not either on x axis, what we say number line. So now the next task is to copy that √2 which is in diagonal in the main number line, that is the horizontal in the x axis. So what we will do then? Now we will copy this line. How? We will measure the length of the diagonal. We have already discussed in class 6 how to copy a line segment. We will measure the length of the diagonal with the help of our rounder and pencil. Then we will take the origin or the intersection of x and y axis, intersection of x and y axis, that is the origin, that is the 0 point as the starting point, and I will make a arc on the right side. I will make an arc on the right side of the origin, means towards the x axis, towards the positive side where I have taken 1. Okay. So that value where the arc will cut the x axis, I will get a point. The arc I will cut, just like you are drawing triangles, you are taking a line and cutting 6 centimeter. Similarly, in scale you are measuring 6 centimeter. Here I will measure the diagonal. I will take the intersection of two axes as the starting point and will cut the arc towards the right side. So here the arc cuts the line, that point is √2. Okay. So using this method you can find the square root of any number, maybe √3, maybe √5, maybe √7. So here I have discussed √3. √3 square is 3. So whose square plus whose square gives 3? It is √2 plus 1, means 2 plus 1 3. So √2 square plus 1 square. So I will take √2 in the base. Already I have calculated √2. So that value is √2 and 1 in the perpendicular. Then I will join them. That value is the diagonal, √3. Okay, but I have to copy that on the number line, but because the diagonal is not the number line, that I got the value, and again I have to copy that on the x axis. Similarly, 5, √5 square, means I have to find out √5. So it is in the form of h, b square plus b square equals to h square. H value I have to find out √5. √5 square is 5. So think of such two numbers whose square gives 5. It is 4 plus 1 or 2 square plus 1 square. Okay. So 2, you can take 2 in the base, 1 in the perpendicular, or 1 in the base, 2 in the perpendicular. You will get. Another way, you will say, sir, 5 equals to 3 plus 2. I will say, yes, no problem, 5 equals to 3 plus 2. So 3 is whose square? It is √3 square. 2 is whose square? It is √2 square. You can follow this method, but it is very lengthy. Why? Now √2 you have calculated. Similarly, you calculate √3. You will take that on the perpendicular, then you will join the diagonal. Means first you will calculate √2, then you will calculate √3, then after that you will be able to calculate √5. So it is always easy to think of such numbers. It is always easy to think the square numbers. Sum is the given value, just like √5. So its square is 5. Think of two such square numbers, that is 4 plus 1 is 5. So 4 is 2 square, 1 is 1 square. But in some cases it is not possible the square numbers. For example, in case of √3. In case of √3, so it is not possible to get two square numbers whose sum is 3. Okay, so the only two numbers is 2 and 1, but 2 is not a square number. So we will take it √2 square plus 1 square. Okay, but it is easy to take the square numbers, and if it is not possible, then you can take any two numbers whose sum is the required one. Okay, so using this method we can find out any irrational numbers. We can show any irrational number, 2 √2, 3 plus √5 in the number line, but generally in our syllabus here we will discuss only the square root of prime numbers 2, 3, 5, 7, just like this. Okay, but we can show 2 plus √5, 5 minus 3 √2, we can show all this, but here we have very simple one. We have to discuss √2, √3, √5, √7, just like this. Next we will go to our exercise 1.2. So the first question you can check, every rational number is a real number. I have discussed every point. Check the second bit, every point on the number line is of the form √m, where m is a natural number. Every point on the natural number is in the form of √m. True or false thing? You will say, sir, 9 is a number, root 9 3. Yes, it is possible. But I have said earlier, the statement will be true if it is always true. You think the number line can represent all real numbers. All real numbers can be represented on the number line, and as discussed above, the square root of all positive numbers are possible. So they are real numbers, but the square root of negative numbers are not possible. So they are not real numbers, they can be shown on the number line. So here the square root of all positive numbers are possible. So rational numbers are also positive. So the square root of rational numbers can be shown on the number line. But here it is saying where m is a natural number. Every point on the number line is of the form root m. So if I will say a number line, if a number is 36 by 49, it is not the square root of any natural number. Okay. So if that m denotes rational number, then the statement is correct. But now the statement is wrong. Next question, bit 3 already discussed. Question number 2. Are the square root of all positive integers irrational? Square root of all positive integers, 1, 2, 3, 4. So the square root of all the positive integers means natural numbers. Square root of all natural numbers. Square root of 1, square root of 2, square root of 3, square root of 4, 5, 6, 7, 8, 9. All are irrational. So you think the square root of all positive integers are irrational or not? Okay. So the square root of, I said, square root of positive numbers are real numbers. So among them there are two parts. Square root of perfect square, square root of square numbers are rational. Example, square root of 4, it is 2, rational. Square root of 36 by 49, okay, that is not an integer. Square root of 25, yes, it is rational. So here it is an all positive integer irrational. No, square root of non-square numbers is irrational. Square number is rational. So the next is root 5, already discussed. Next is classroom activity. It is not to be done here. We will discuss when the school reopens. It is a type of activity. We will do something with the help of pen and paper. It will like activity 1. So this is end of our chapter 1's first 2 exercise. So thank you all. In the next class, we will meet with the decimal expansion of irrational numbers. Till then, thank you. Thank you all.